Hey, hello everyone. How was your weekend?
It's I was great.
Productive?
A little too productive.
Good. Did you get to the homework on chapter 6? Did you start doing homework? It is? Great. Wonderful. So, you guys are very quiet in our last class when we went about these topics. Be honest with me. Did you guys understand the concept or you did not? If anybody who is not comfortable with the materials we learned in our last class, do you want me to do anything before we start the new concept? Do you want me to go over anything from our last class or anything in general? No? Okay, so in our last class we learned about multiplication rule. So we use multiplication rule when we use the word and. Okay, when we use word or, we use addition rule. But when you work with and, we have to work with multiplication rule. Now, multiplication rule is same for two scenarios, with replacement and without replacement. There's only one difference. When you do with replacement, it means every time we are picking something but putting it back. As a result, the total sample size is never changing. So denominators are same for everything. The difference between this scenario and other scenario when we have without replacement means we are picking something, but we are not replacing it back. So each time we pick something, we are reducing the size of our sample space. As a result, for every event we find the probability for, the denominator is reduced by 1 unit. Okay? And the rule says, anytime you have and, it means you multiply the two probabilities. And two events, they're independent. If the probability of their together, probability A and B, is a product of the individual probabilities. Means probability of A and B is probability of A times probability of B. So this is the multiplication rule. Now, based on that, we have a new concept, conditional probability. Conditional probability is something when one event is depend on the other event, or one probability of one event is not independent of the probability of the other event. Okay, so they have some relation, some connection. So conditional probability is defined as the likelihood of an event or outcome occurring based on the occurrence of the previous event or outcome. In other words, the conditional probability of the event A, given that the event B has already occurred, is A given B, probability of A given B equals probability of A and B divided by probability of B. That word given, we can replace with a vertical bar. So we said probability of A bar B, that bar means given, equals A and B, probability of A and B, divided by probability of B. So whatever already has happened, we divide probability of that, divide by the probability of that. Okay? This equation actually has another format, and we call it bias law or something. But we're not going to talk about bias law in this class. In this class, if you use this, only this one equation, you'll be fine. The when two events, they're somehow related, one is different than the other one, we use conditional probability. For example, we have a chart where we have some football fan, not football fan, and agree and disagree. So two variables you're working with together. One is something they're agreeing or disagreeing with, and the other one is they're being football fan or not being a football fan. So when you add all the people, it's add up to 2096, 20,096 people. Now let's say A is the event selected participant agrees with something, D is he disagrees with something, and F means he's a football fan. So these are the three symbols. Now, what is the probability of A? It means what is the probability of agrees?
922 over 2000.
Right. Agree, the total is 922. So probability means likelihood of an event divided by the total sample size. On total sample size, the total people you're working with 2096. So agree divided by 2096, that gives us the probability. Oh man. Okay. So probability of agree is total people of agrees divided by the total sample size. In other words, 922 divided by 2096. You didn't have to do anything else in this class. I just want to see, did you understand the concept? So no reduction is needed. No simplification is needed. It is fine. Who wants to be? Probability of disagree. You can just give me the number, 100. Wonderful. 1174 divided by 2096. So total people we have under disagree is 1174 out of total 2096 people. Cool, right? These are simple ones. Now comes the conditional probability. What's the probability that the person you're picking, he agrees, given that he is a football fan? Tell me the number. 922. 2096. Over what? 2096. Very close, but I don't think it's quite right. 2096. Then it's definitely wrong. You know why? When we cancel 2096, 2095, 922. What's the root of the probability? It has to be between which two numbers? 0 and 1. But what's the probability you got? 922. Your idea is okay. You're going in the right track. I think you're missing.
698 over 1000.
698 over 1 to 16. Okay, so let me list this. Any other answer? 693? Or say 693 or 698? Did you say 693? Okay. Any other answer? I didn't take the answer yet. I'm just collecting all the guesses. Any other guesses? You can be wrong, no problem. See, when you're wrong, I can help you to figure out why you are wrong. Like, see, I told him why he is wrong. So this probability is too high. So now, anyone, any brave one who wants my help to figure out why they are wrong?
Disagree.
Because look at here. Only a football fan, it could agree or it could disagree. Or if you're not a football fan, you could agree or you could disagree. So you have four choices. Exactly. Just because you disagree, it doesn't mean you are not a football fan. Or you are a football fan, right? There are two choices. One of them is not guaranteed, one of them does not guarantee the other one. So any other guesses? Or do all of you think that is correct? Correct? Okay, then it must be correct. Let's see. So it says, what's the probability of being agree given that you're a football fan? So agree and football fan, we have 693. Agree and football fan, and we have total. Oh, let me write down the equation. The equation says it's probability of agree and football fan divided by probability of football fan. So if you do it this way, agree and football fan is 693 over this. I'm showing you the details. 693 over 2096. This is the definition, right? Conditional probability of something given something is probability of their intersection divided by whatever already happens.
But I feel like 293 and 693. And also
693. That's total. So what's the probability? I'm just doing the probability of this. What's the probability of agree and football fan? So it's agree and football fan divided by total people, right? The individual one I'm talking about. It will. I'm showing you why. Or if you use a formal definition, how the answer will give you the final shortcut one. The two ways of doing it, shortcuts or the details. Okay? Some people see the shortcut directly, like most of you, but some people need the details to go to the shortcut one. So I'm giving you both choices, both answers, okay? Both methods. This is a shortcut, but how did you figure it out? Well, this is a long cut. How did you figure it out? So probability of this one is only is this divided by the total people. So this agree and football fan 693 divided by 2096. And the probability of football fan, we already know, actually didn't. For the football one is 1216 divided by 2096, right? Football divided by total. So we have 1216 divided by 2096. Now what happens? They cancel out. And that's how we can write this down as 693 divided by 121. Yes, definitely you can use a shortcut. I actually prefer using a shortcut. But from my experience, many of you, when you try doing the shortcut, you mess up. So in the exam, if you have time, please try both. Check your work with the details method, but you can definitely use a shortcut.
On the exam, when we're answering questions like this, are we going to provide the table that has all the things?
If not, if one of them is missing, you can definitely figure out, right?
Yeah.
By subtracting. Okay. Then what's the probability of being a football? agree given that it's not a football fan?
I said, 880.
229 over 880. Anybody disagree? No? Anybody did not understand why it's 229 over 880? So probability of agree but not football fan is 229. And then from this experience, we can already see all you have to do is divided by probability of football fan. So this case, we have probability of not football fan, which is 880. So agree but not football fan 229 divided by not football fan. Shortcut. Do any of you need to see the details? How did you figure out the shortcut? Do you have a question or do you want me to show you the details? Then let's apply our definition. Our definition says probability of agree given not football fan is probability of agree and not football fan divided by probability of not football fan. FC series complement. So agree but not football fan. So these are agree column, these are not football fan column. They intersect at 229. So we have total 229 divided by 2096. And then probability of not football fan. Probability of not football fan, we have total 880 people. So 880 people out of total 2096 people. They cancel out. We're left with 229 over 880.
I thought when it was N. But
If they're individual. Sorry, if they're independent.
oh, so
They're not independent, right? Because they have some connection. You could be, you could agree, but be not football fan. Or you could agree and be a football fan. So they are not independent.
there's like on this equation, you have A, not little than on the top. Then where is it 2026? Or is it just
Just observe this one. What is the probability of A and not football fan? So first, let's talk about what is the probability of football fan. What is this? Not football fan. So how do you find probability of not football fan?
220?
Right. Not football fan, 880 over this one. Right? Only not football fan, nothing else. Single not football fan is total number of not football divided by total number of sample size. So this is single one. Not two. 880. 880 divided by 2096. Right? Okay. Now it says take someone agrees but not football. So agrees and not football. How many you have agrees but not football? Right. So agrees but not football divided by total number of people. So 229 divided by 2096. Now the rule says this divided by this. So in division, you cancel the denominators. You left it numerator divided by. Any other question? Anybody did not understand what we did? No? Come on, guys. I want you to have fun. Why are you not having fun? What's wrong with this? Is it hard, confusing, or you simply don't care? Which one? I don't care, to be honest. But see, I have to care. Sure. So, disagree on what? Football fan or not football fan? Which one? Okay. So you want to find what is the probability of being disagree, but he's not football fan. So it's mean probability of disagree and not football fan divided by probability of not football fan. So how many people we have disagreed that is not football fan? 651. So 651 goes on the top. And how many we have not football fan at all? Not football fan. 880, right? Do you see it here? That's it. See the shortcut. Because the denominator going to cancel anyway. So you have to remember the denominators. You can simply take the numerators for both probabilities. Is it better now? Guess what? This was a previous final result. So there's a high possibility of having this in your finals. Any question? Can I flip my pages? No? Okay. The next one. Actually, final exam question was more like this one. But it's based on the other one. Okay, let's read it together. There were 3 directors who made 3 different types of movies: detective, sci-fi, and love stories. Then it says, after watching the movies, viewers were asked to give their opinion on whether they liked or disliked the movie they watched. 50 people watched detective stories, 30 watched sci-fi, and 40 watched love stories. 40 people said they liked detective stories, 10 said they disliked sci-fi, and 30 says they liked love stories. So many combinations, right? So when you say combination of everything, make a chart. Whatever is easier for you. For me, I like to have, just like the previous one, like, dislike, whether they like it or dislike it. And then we have 3 types of movies: detective, what else? Sci-fi, and love. So 2 columns, 3 rows. If you want, you can put 2 rows, 3 columns. And now move this out. We have what? 50 people watch detective stories. So the total detective was 50. Then 30 watched sci-fi and 40 watched love stories. So these are total number. 30 and 40. So how many total viewers we have? 120. Now among these, 40 says they like detective stories. So where do we put 40 here? Detective like, right? So under detective and like, we have 40. That means, do we know how many dislike the detective stories? 10. See how smart we are? They did not give us the information, but we still could figure that out. Two. Now, 10 people said they dislike sci-fi. So where do I put this 10? Sci-fi and dislike, right? So sci-fi and dislike is here, we put 10 here. That means how many liked sci-fi? 20. Because we have total 30 people who watch sci-fi. I hate sci-fi, you know? It's too unknown. But I love detective. This is my favorite. 30 people says they like love stories. So like and love, oh, they're together, cool. Like and love, we have 30 here. So how many people dislike love? 10. See, they give us happy information, but they filled out the whole chart. Let's do total. How many total like we have? 90. How many total dislike we have? 30. So all of these are total. Okay. Now let's see what they want us to figure out. If one of these viewers was asked randomly, what is the probability that he or she liked the movie? So what you're finding, probability of what? Probability of like. So what's the probability of like? We have total 90 like out of total 120 people. So 90 out of 120. Easy, right? Okay, then you try the next one. Do I have more? Yeah, let me put everything together. Give me 1 second. Okay, go ahead. Try this. And let me take that attendance. Today is what? 9:23. Ellison? Danielle? Danielle? No. Lacey? Yasmin? Ryan? Yeah. Janae? Anton? Christina? Didimichi? Yeah. Christopher? Christopher? Nyako? Noor? Noor? Ramesh? Yeah. Jamina? Absent. Waiting? Waiting? Absent. Xian? Tao? Lila? Lila? Jason Lu? Yusuf? Isabella? Nitya here. Kevin? Salma? Peace? Karina? Maria? Mia? Absent. Tahmina? Wendy? Sebastian? Fatima? Emanab? Emanab Wasif? Queenie? And Jason Joe? Jason? No. Okay, Crystal Gala. B. What out of what? 3 out of 4? Let's see. One viewer was asked randomly from the liked people who liked movies. What's the probability that they like love story? So it's a conditional probability. Probability that they like movies given that they watch love stories. That means probability of love and like, oh, let me just put love, it's easier. Divided by probability of love, right? So like and love. Like and love, we have 30 and divided by love, total love is 40. Wonderful. It is 3 out of 4. Thirty out of 40. Who is confused? People who liked. Oh, it's the other way around, right? Yeah. What is the probability that whoever they picked who liked the movies, from them, what's the probability that they like the love story? Oh. Other way around. No, let's oh. So probability that they liked love, given that they liked their movie they watched. So love, probability of love and like divided by probability of liked. So like and love same. We have total like and love 30. Let me change the color. Like and love 30 and divided by total love. So divided by total like is 90. So 30 out of 90. 3 out of 9. Do you see? Thank you for catching our errors. I make lots of mistakes. And I'm not, I don't think so either. Because when I make mistake, you can catch me, right? That is your attention in the part. Which is a positive thing.
I have a question. Do you prefer us to leave the probabilities in the full form of 90 over 120? Or do you want us to simplify it to?
Just number is fine. Because my goal is to see whether you understood the concept. Math portion is in calculator, so let me know that. Plus, it's easier for me to see the results from there. Okay, who would like to try C? Tao, would you like to try C? Whatever what? Whatever what?
1/3.
1/3. How did you get that? Whatever what? Without.
It's like, yeah, down to it's like hollow. It's that it's like sci-fi.
So sci-fi, given that is liked. So probability of sci-fi and disliked divided by what? It's a conditional, right? Probability of sci-fi and dislike divided by probability of dislike. So we have sci-fi but dislike 10%. They watch sci-fi but they dislike that, like me. We have 10 divided by total dislike. Oops, Total dislike is 30. So we have 10 out of 30, which is 1/3. Any question? No question? Is anybody confused? Tell me which part is missing. Right, from the beginning. Is this figuring out the equation?
Yes.
If a viewer was asked random, so from 120 people, you picked one person. From the people who dislike the movies. Okay, so we have total 30 people that dislike movies. So our sample space got reduced from 120 to 30, right? Because from 120, there are 30 people who disliked movies. So from these 30 people, what is the probability that he watched sci-fi? So from the people who disliked, what's the probability that they watched sci-fi? So you see our sample size is 30 now. That means our denominator is 30. In this 30, how many watch sci-fi? How about B? Are you okay with B? Did you understand B? Okay. How come you got quiet? You understand now? Oh. It's okay, we all learn. So 30, 90, 30, 10, 91, 20, perfect. Any question before you move on to the next topic? The next one is based on counting rules. How do you count? So if an experiment consists of 3 steps, and first step has M outcomes, second step has N outcomes, and third step has K outcome, then the total number of outcome is their product. That's the rule. We call it counting rule. Depending on your step, however many outcomes you have, you just keep multiplying all the outcomes for every steps. Now we all are familiar with factorial from pre-calculus, right? We did factorial in pre-calculus. Factorial means we are multiplying all the numbers from 1 until the number has the factorial. So if we have 5 factorial, what is 5 factorial? 5, 4, 3, 2, 1, right? Multiply all of them. So factorial means keep multiplying starting from 1 until the number has a factorial. And that's a fun example. So we already did 5, 5, 4, 3, 2, 1. How about 4 factorial? 4, 3, 2, 1. So do you see the same amount for this we have here, right? This is cool, right? So we can simply write this as 5 times 4 factorial. Can we? We can, right? What is 3 factorial? 3, 2, 1. 3, 2, 1. But observe, whatever we have for 3 factorial, we have here. Ah, did you notice? Yellow and blue makes green. Oh. So we have 4 times 3 factorial. So we can simplify our factorials by keeping the bigger numbers and the smaller numbers we can just put factorial. It's helpful when you have factorials at the top and bottom the same numbers, you can simply cancel them. And then we have 2 times 1, which is here, stood out. So it's 3 times 2 factorial. So this one we can write actually 5 times 4 times 3 factorial, or we can write 5 times, 4 times, 3 times, 2 factorial, right? We can vectorize factorials however way we want. What is 1 factorial? Simply 1. Now comes $1,000,000 question. What is 0 factorial? That's why I say it's $1,000,000 question. The answer should be 0, right? It's not.
Well, if you want to count nothing.
It's 1. Surprising, right? 0 factorial should be 0 times nothing, right? Right, it's really 1. So why do we care? Well, we actually use this thingy many times in our life without even realizing it. One example, a simple example. A salesman he has 3 cities to go, or 3 ways he can commute somewhere. How many possible routes he has? So this is the salesperson. And he has city A, city B, city C to go. How many ways he can visit all 3 cities, Ryan? How did you figure that out? 3 factorial. Why do you think 3 factorial?
Because there's 3 seconds.
We have 3 separate cities. He can, when he starts his journey, he has 3 places to go. Let's say he went to B. And now how many places he has to go? Either A or C. So 2 choices. Let's say he went to A. Now what is his last resort? C. So this is counting rule. You start by your steps. In first step, he has 3 choices. Once he done with his first step, now he has 2 choices. So once he done with second choice, now he has only 1 choice left. So 3 times 2 times 1. We multiplied all the outcomes. And that gives us 3 factorial 46. Is anybody confused? No. I love this type of question, so I'll give this probably in the exam as simple question. Oh, not final, sorry, exam. They don't require any math, they just require some logic. Okay. Now comes combination. And in combination, we use the factorial. Combinations are known as selecting R objects or numbers from n groups of objects for collection in such a way that the order of the object does not matter. We denote that as NCR, or sometimes simply n on the top, r on the bottom, in a parenthesis. And its definition is n factorial divided by r factorial times their differences factorial. You don't have to memorize that, you can simply put in your cheat sheet. When do we use this? To win a state lottery, you need to select 6 numbers from 54 numbers. How many ways you can select 6 numbers from the 54 numbers? You are selecting 6 numbers from 54 numbers. So when you select one number, does that mean you cannot select the same number again? All right? You can select the same number again and again and again. So the order doesn't matter. For the series, you see, once you pick something, you cannot pick it again. So the order did matter on the last one. But here, it doesn't matter. You can pick the same number again and again. So, since the order doesn't matter, this is an example of NCR. Total, how many numbers you have? 54. And you're choosing how many numbers? 6. So 54 factorial divided by 6 factorial minus times 54 minus 6 factorial. 54 factorial, 6 factorial. What is 54 minus 6? 43 factorial. 14, 8. 48. You can use the calculator to simplify. For this class, I actually don't mind. Keep it, no problem. Do you have the answer? Cool, tell me, it should be a big number. Tell me the numbers. 25? 6, 5. Huh? Leave it, no problem. Because you're using calculator anyway, right? So why wasting your time? I want to see the concept. Did you understand the concept? And also there is another reason. Our exam is only 1 hour 15 minutes. So if you waste your time doing the calculation, you're wasting your time. You don't have much time. So 54 to 6, that's the answer. The next one. Now, combination has a partner. This partner's name is permutation. Combination doesn't care about the order of the numbers, but permutation does. So when you're working with some scenario where the order does matter, then it's not combination, it's permutation. For example, when you come in the classroom, the very first person, when he or she comes in, he or she has so many choices, right? All the seats, she or he can sit anywhere. But once she chooses a seat, can second person come and move her from the seat? Good. Right, but appropriate, right? The seat is taken. So the second person sits somewhere else. Then when the third person comes, he cannot remove the 2 persons, right? The second seat is taken, so he has less choices left. So he goes and pick the third one. So that more person comes, later they get less and less choices left. So the order of the person they are coming in, it does matter, right? So this is the permutation. And here comes my favorite, one of my favorite examples. Not this one, the next one. This one says how many ways you can arrange 5 books in a bookshelf. Think about this. Does the order matter? It doesn't matter. So we have 1, 2, 3, 4, 5 books. And you have 1, 2, 3, 4, 5 places. Okay? So for the first book, how many places is available? For the first book, we have 5 choices, right? Book number 1, he's a king. He has 5 choices. Let's say we set book number 1 here. Now comes book number 2. Choices. Now for the second book, how many choices we have? 4. Let's say I'm putting my second book here. Now comes book number 3. So for the third book, how many choices we have? 3. Let's say I'm putting it here. For the fourth book, how many choices we have? 2. Let's say I'm putting it here. That means when the last one comes, how many choices we have left? 1. Remember the factorial, the choices, the outcomes you have in each trial, you multiply all of them. So it's 5 times 4 times 3 times 2 times 1, which is simply 5 factorial. In other words, this is 5 choose, not choose pick. What? If you do pick, what it would be? 5 pick 5? 5 pick 5. 5 pick 5 or 5 factorial. The answer is either 5 factorial or 5 pick 5. It cannot be 5 choose 5. 5 choose 5 is wrong. 5 pick 5 is correct. Because the order of your placement holder doesn't. So the formula says the totals divided by whatever you are picking minus the total. So 5 divided by 5 minus 5 factorial, which is 0 factorial. And what is 0 factorial? 1. That's what the answer is 5 factorial. Done? Third question. Go over again. So let me erase this. We have 5 books, 5 places. So for book number 1, how many places we have available? 5. So book 1 has 5 choices. So let's say I placed my book number 1 here. So this place is done. Second seat is done. We cannot put book here anymore. So for our second book, how many choices we have left? 4. So the first one has n choice, the next one has n minus 1, the next one is n minus 2, then n minus 3, which is same as the factorial. 5 factorial, 5, then 4, then 3, then 2, then 1. Combining all of them together, becomes 5 factorial. That was my favorite. I'll give you a different scenario, but same concept. You're riding on a bus, and that bus has 35 seats. Doesn't have unlimited seats. It has only 35 seats. Now, how many ways in that bus 10 people can see it. They are not entering at the same time. Okay? The 10 people, they are entering one by one. Think about the concept. From the 10 people, when the first person gets on the bus, how many seats is available for him? 35. Now comes the second person. How many seats he has? 34. So we have person 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 person. For the first person, we have 35 seats. 35 seats. Second person has 34, right? How about the third person? 33. The next person, 32. Next person, 31. The next one, 30. Next one, 29. Next, 28. Next, and next, 26. The counting rule says all those outcomes, you multiply them, that is your answer. So it's 35 times 34 times 33 times 32, that's until you reach 26. That is logic, okay? But let's say you're too lazy to use logic, just memorize everything. Then how are you going to solve this question? Are you going to pick P or C? Why P? Right, same question, right? Same answer? True. If you are lazy about logic, thinking, you are good at memorizing, no problem. It's simply NPR. NPR. So what is our N here? 35. And how many are picking? 10. So 35 factorial divided by 35 minus 10 factorial. So 35 factorial divided by what? 25 factorial. And now you may wonder, well, how come both answers are same? They look different, right? But remember the method I showed you before? 5 factorial is 5 times 4 factorial. Well, we can do the same thing here. 25 factorial, we leave them alone. And then we have 26, 27 until 35 divided by the 25 factorial. What remains? 35 to 26, all the numbers you multiply. See? This is my favorite. This is my favorite. Look, every time I get on the bus, this reminds me of, like when I get on the bus, I always remember this question. Oh, how many choices I have? Huh? Can you explain? So, did you understand before that 5 factorial is 5 times 4 factorial? And I said, well, we can read it as 5 times 3 times 5 times 4 times 3 factorial, right? So here our denominator is 25 factorial. And I know I already have 25 factorial inside 35 factorial, right? Because 35 is 1 times all the numbers until 35. So all the numbers 1 to 25 gives us 25 factorials. That means we left with 26 before, and then before that we left with 27, and then we left with 28, 29, 30, 31, 32, 33, 34, 35, right? So 35 times 34 times 33 times all the way to 26, and then I'm stopping and writing 25 factorials. Why? Because we can actually cancel the 25 factors from the top and the bottom. So I didn't have to write 1 times, 2 times, 3 times until 25. I can simply cancel them. So you left with the same answer as the left side. All the numbers you multiply, from 35 to 26. So this is a trick about factorials. We don't have to write down factorials for everything. We can write down whatever we need, and we can cancel the rest. For example, let me show you one example with easy ones. Let's say 8 factorial divided by 4 factorial. Well, we know that factorial is 8, 7, 6, 5, 4, 3, 2, 1, right? 4 factorial is 4, 3, 2, 1. So you see we are canceling all the 4 factorials. That means we left with all the numbers from 8 to 5. So I use the same concept here. We have to multiply all the numbers from 1 to 35. Why wasting our energy? Let's multiply 26 to 35, and the 25 factorial cancel the denominator. And with this, we are done with chapter 6. Okay, we are done with probability. So any question on probability? Christina, still confused? She helped you, did you understand now? Okay. For my class, if you just write this, I'll be happy. You don't have time, so I'll be happy. But you should know how to do everything, because maybe in your next class, you need it. Your next professor may not be as generous as I am. Okay, so do you have any question from anything from chapter 1 to chapter 6? Next one, 14 or something, right? It's our syllabus. 14? October 14.
Oh,
It's a Monday.
maybe I double check.
It's
Is
not
that Monday or not?
That's full of the circle. That one is that.
Of the 15th, there's a Monday schedule.
So we want. Because she has classes.
But,
So
That was
20, 21? 21st? Okay. So yeah, first I decided to 14 and then I saw it. So let me show you the syllabus again. So yeah, October 14, no class. October 2nd, no class. Ooh. And October 15 should be a 14 Monday schedule, no class. So our exam is October 21st. Okay, so do you want to start chapter 7? Huh? Okay, so we'll leave chapter 7 for our next class Wednesday. And try doing your homework on 6. Huh? Anything that is the square root function and the NCI and PSI. Fine. So yeah, goodbye everyone. Have a good day. Have a good night, actually. You did not. Okay, let's